Hi, everyone. Welcome to our final lecture in the series of research methods. And you may recall in an earlier lesson, we talked about external validity and generalizability. Well, this particular lesson is all about generalizing results from your sample to the population at large. I think it has great use when you think about the limitations of one's research. You'll see the people talk about the limitations of their research in a discussion section of an article. But anyway, here we go. So the first learning objective for this particular lecture is to discuss the issues created by generalizing research to other populations, problems that emerge by using college students as research participants, understanding the impact of culture and ethnic groups, and generalizing across ethnic groups without a representative sample, generalizing to other experimenters, and talking about the difference between mundane realism and experimental realism. We'll also talk about the powerful effect of replications and replication studies, and how replication and replication studies increase your ability to do generalizations. We'll also distinguish between exact replications and conceptual replications, and we'll address the difference between a narrative literature review versus a meta-analysis. Okay, so here we go. In lecture 5, in lecture 8, and so forth, and actually I think lecture 1, the first lecture in this series, we talked about different types of validity: internal validity, external validity, and construct validity. And you may recall the term internal validity was the extent to which you can say you have a causal relationship between your variables. External validity was looking at the extent to which your results can be generalized. So in other words, we're looking at whether the results of a single study can be generalized to other research populations or to other ways of manipulating the variables. So let's pull out a bigger picture. In general, the vast majority of research done in the human model is done with college students, and in the animal model is done with rats or other rodents. So research indicates that nearly 7 out of every 10 studies use college students. And because there's a requirement in some early courses, many of which are freshmen and sophomores. So it tends to lean towards a younger sample, individuals in young adolescence or the beginning of emerging adulthood, right? So there's an age-related factor that we have to think about whether it generalizes across the lifespan. We also, in choosing a college sample, tend to have more highly intelligent individuals on average, have higher cognitive abilities, and know how to seek approval. Now, we talked about in a previous lecture on surveys, the concept of social desirability and how people might modify their answers to seek approval or social validation. And in terms of the animal model, most research comes from the white rat, as I've said. So we have to think about whether the rat model generalizes to other animals or the human animal for that matter. Now, the problem that I'm trying to frame for us on this slide is that we're trying to generalize to a population at large from a very highly restricted population, and that's problematic. We also want to think about the fact that most studies utilize convenience sampling. So convenience sampling occurs when we just take volunteers, right? So when you have volunteers or your studies dependent on volunteers, it's possible that volunteers respond differently than non-volunteers. And in an early study by Rosenthal and Rosno, they found that volunteers tend to have higher levels of education, socioeconomic status, and a greater need for social approval than non-volunteers. We also see that a title can influence whether people participate in a study or not. So the more provocative the title, the more likely you're going to get clicks for your study or volunteers for your study. All right. Gender. When we talk about research, we also see that there is a challenge with male to female ratios, and this is common in psychology. When we look at the psychology major, there's an overwhelming majority of females who are in the psychology major. So when you're doing research through a psychology participant pool and you're relying on volunteers, it's possible that you could get some skew towards females to males, sometimes as high as a 2-to-1 ratio. And that affects generalizability. Now, there are some studies where the procedures are suited towards one gender. For example, if we were doing research on eating disorders, we know the prevalence rate for females is almost 10-to-1 relative to males when it comes to eating disorders. So in your procedures, you might design your study targeting specifically females. And at that point, it's not a problem because you're not looking to generalize from one gender to the other. But if you are looking to generalize from one gender to any other gender expression, then you really have to make sure that the ratio is commensurate with the general population. And even what's on this slide, I really think that we should reconceptualize our responses on demographics, because gender is not binary, right? So you can have gender fluid and many other options to the gender category and conceptualize your study that way. So even if you had male and female options, would it generalize to other gender minority groups? So it's something to think about when doing your research, gender consideration. We also have to think of locale. Where you do a study impacts the kind of participants you have, and you may not be able to generalize from one locale or one geographic area to another. So, for example, if people go to UCLA, they might differ from other individuals who are in a nearby state school. Right? The population is different, or the student body is different, right? And these people in turn might differ from students at a community college. And if we shift geography still within the United States, New York participants might differ from people born in California, right? So there's something to think about locale and geography and how that plays a role. Certainly when you're doing cross-cultural research, right? We know that there are sweeping differences in identity between those individuals who come from westernized nations versus more collectivistic nations. So generalizing your findings from the United States or anywhere in the United States, on average, likely would not fit findings in India or China, right? And that's important to understand because values, the macro culture could influence the values of the respondents. So it seems like the criticism that I've leveled is like, well, then why do research? Everything has a problem. No, I want you to understand that it's not necessarily a problem, it's a limitation, right? And just because you have to think about whether your results generalize doesn't mean that they don't generalize, right? So, again, so if you're going to say don't use college students or rats, you have to have a good reason why these individual students or rats might not be appropriate. So you have to have good reasons why it would not generalize. We know it possibly wouldn't, but to invalidate that research altogether, we wouldn't do that. Now, another safeguard, as I said, is uh, replication studies. So if you do the same study with different participants, potentially across different areas, geography, gender, culture, and you find similar or consistent findings, then you have more confidence in the outcome and you're more likely to be able to generalize. Now, the animal model actually has been used for many years to apply to human beings. And in fact, we see that animal studies have given us great insight as to how we might engage in behavior modification, understand personality, choice behavior, memory, and so forth. So I don't want us to throw the baby out with the bathwater, as that old expression goes. I want us just to know the potential limitations of our study and how that affects our ability to generalize. Now, I mentioned culture and cultural considerations. If we look at research, until more recently, much of the research was done with white, middle class, uh, educated college students, and it did not have much diversity at all. And in fact, when we think of some of the identity development models, the earliest identity development models that started to get traction, we're looking at the 1970s. So we have IQ tests, we have personality measures, we have a whole host of research pre 1970 that was done based on a white sample. So that might, because of the homogeneity and the restriction of range, as I've talked to you about in the lecture on correlation, that might impact your results and it might affect your ability to generalize. However, I will tell you that most samples of college students today are far more diverse than the early research in psychology. It tends to focus on a more diverse population across age, gender, ability, ethnicity, religion, socioeconomic status. So it is the research today is far better and it's richer because of the fact that the data is more representative of the population as a whole, right? So there are research studies that do still look at individual differences between cultures and similarities across cultures. So if you're interested in that you could take a course in cross-cultural psychology, and it goes through all the similarities and differences um, of across culture. All right. So this also provides us some, on a large scale, bird's eye level, uh, some understanding about how to generalize from one culture to another. So if we were to look at ratings of attractiveness for females, and we were to have various ethnic groups, and you were to show them photographs and discover who's more attractive than the next, we find that if it's the face only, there is a 0.93 correlation across culture, across ethnicity. It's remarkable. There are certain features that in all societies we tend to find attractive, like symmetry, accentuating the eyes and high cheekbones and so forth. There's a list of features that are objectively beautiful across culture. But when it comes to the face and the body, what we see is a difference between Asians as a group relative to white, Black, and Hispanic individuals. So we tend to see white, Black, and Hispanic individuals preferring a more fully figured, more sexually mature body type than Asians as a whole, according to these research studies. Now, even self-concept, how we see ourselves, is different across culture. So when we look at Western culture versus East Asian culture, where do we develop a sense of self-enhancement, fulfillment? In Western society, it's about individual achievement. And you might hear a phrase that goes with that called the squeaky wheel gets the grease, right? So you draw attention to yourself. When it comes to East Asian cultures, there tends to be more of a collectivistic approach. So your personal enhancement comes from the group as a whole doing well. And that you don't want to stand out as an individual. You look for symmetry and the group doing well and getting similar or same outcomes. And you might hear the Asian proverb, the nail that sticks out gets hammered in, seeking symmetry, not calling undue attention to oneself, right? So there are differences. So Hazel Marcus and Shinobu Kitayama did a lot of research on some of the cross-cultural considerations here. So it's important to be aware of the ways in which operational definitions impact cultural meaning, right? So a measure of self-esteem that could work in a Western culture may not be as effective in Eastern cultures. Therefore, when we're doing research, we want to be careful either not to generalize from culture to culture, or if we do, that we use measures that are more likely to generalize. For example, I always encourage people to use the Big Five because it has more cross-cultural validity when studying personality. All right. So generalizing from one experimenter to another, right? So we have to understand the experimenter's influence. In an earlier lesson, in the practical side of experimentation, I talked to you about the experimenter influences, right? So an experimenter could, in of themselves, alter a response, right? So in many studies, you have one experimenter being used. So we don't even have the ability to assess individual differences across researchers. So the personality of that researcher, the gender of that researcher, the experience of that researcher, all could be on full display and impact the results. For example, if you have a warm and friendly experimenter, they're going to get different results than if you have a cold experimenter, right? So if participants respond differently when the researcher is male versus female. We also know that well-trained experimenters are going to get different results than lesser experienced researchers. So how do you handle it? So one solution is to have a minimum of 2 researchers collecting data, preferably including male and female, right? So that you could say that your results you don't have some form of experimenter bias or experimenter influence on the results. So Should we give a pretest, right? So we talked about the Solomon four groups design and things of that nature. Should we give a pretest? So your knee-jerk reaction would be giving a pretest seems like a good idea. However, one of the problems with a pretest is that you could alter the responses on the post-test by tipping them off. So if those individuals that get a pretest could have a problem. So let's look at pros and cons. And I believe in the lecture on complex research design, I also touched upon a lot of this. So what are the benefits of the pretest? Well, the first benefit is that you can ensure that the groups are equal, right? So doing a pretest, okay, you could say even before you do your intervention, the groups are roughly the same. You also can assess mortality effects, right? Dropping out from a study, right? So what's interesting is that what if some more people drop out from one condition over another? The pretest might tip you off as to why disproportionate numbers in one group are dropping out over the other. And the pretest, if you're doing some kind of intervention on reducing depression or things like that, it can be satisfying that you can chart improvement over time, right? So those are some benefits. However, the question is whether or not when you give a pretest, it could generalize out to those who didn't get a pretest. And, in many scenarios in the real world, people rarely get pretest or tested prior to a natural occurrence, right? But that doesn't mean that you can just throw it away entirely. A pretest, you could test for a pretest effect, as I mentioned earlier, using the Solomon four groups design. And if the group that received the pretest in the treatment group performed disproportionately different from the other groups, then you know that you have a pretest effect. So it doesn't eliminate the pretest effect, but you can at least assess whether the pretest altered your results. So those are points on that. We also talked about field research versus lab research, right? So when we talk about lab research, it's a trade-off. What you get from lab research is greater control over confounding variables, which means that you have greater ability to say the independent variable cause changes to the dependent variable in an experiment, right? So you strengthen your internal validity, but there are questions whether the lab experience mirrors the real world. So there is an argument that the artificiality of a lab may not generalize to the real world. So it's a trade-off in external validity or generalizability. So one suggestion proposed is to do field experiments, which are designed as studies that are happening in the real world, happening in the environment, right? The true environment, right? So we hope that it reflects everyday life. However, it still could be contrived and artificial. And then you also have to consider one of the reasons why people use lab studies is that they have more control over confounds. Field experiments, you have less control over the environment and confounds. All right. So then we'll talk about mundane versus experimental realism. When we talk about mundane realism, it's whether or not the experiment bears similarity to events in the real world, right? So it's possible that the experiment reflects the real world, but also is totally boring, so people don't participate, right? So you can have experiments of mundane realism and not experimental realism and vice versa. So Experimental realism is answering the question as to whether the experiment has an effect or impact on participant, involves them, and makes them take the experiment seriously, right? So uh, if you have um, a, a study that mirrors the real world, but it's boring, fine, you have the mundane realism, but you don't have the experimental realism, and vice versa. You can have people take things seriously, but it doesn't reflect the real world. So you have experimental realism, but not mundane realism. Ideally, you should have both, though. All right. So there are benefits of doing lab versus field research. I think I talked to you about the strengths and weaknesses of each of those, both in this lecture and in previous lectures. As a reminder, lab research, you have greater control over the independent variable, dependent variable, and confounds. So the internal validity is there. Field research, in general, you have more generalizability, more realism. So there's that. However, it's not either or. The way we see it is that lab research and field research are not in competition, but they complement one another and they give you a fuller picture of the finding. And the more studies that are done across different approaches, more generalizability you have. So, replications, which is to repeat an experiment to see if it can be duplicated. There are different types of replications. There's an exact replication in which you try and go into their method section and copy their procedures from A to Z as if it were a recipe. So you want to make sure it's absolutely the same. That's an exact replication. And this has its value. Exact replications is kind of a quality control check on the outcome. Whereas a conceptual replication is where you use different procedures, maybe different instruments, but you're measuring the same concept. So you're measuring the same concept using different procedures in an attempt to replicate the research findings, right? And both of these have value. So a conceptual replication, one of the benefits is you can say it wasn't the test that you used. It wasn't the sample that you had. The fact that you can get the same or similar findings provides a sense of convergent validity, right? Provides a sense of reproducibility of an outcome. This is all good. So when we talk about exact replications, let's look at what could happen. What happens if you get unexpected results? So if you do a study and you find a phenomenon that was out of the blue, the best thing you could do is an exact replication, because you might think that the initial outcome was an error or some error variance, right? So your all scores are a combination of true abilities plus error. So you reproduce it. And in fact, when we talk about Pavlov, well, Pavlov wasn't interested in classical conditioning. He believed in a salivation reflex, but he saw something unusual, so he designed a study to reproduce it over a series of time, right? So he questioned his own work, but if you get an unexpected result, first thing you do is repeat the trials and see if you get the same or similar outcomes. So you also, if you're doing groundbreaking research, you're going to want to replicate the findings. So let's talk about drug studies and the remarkable COVID-19 vaccines that came out. That wasn't one study. They did trial after trial after trial in order to see if there was consistent outcomes and look for adverse negative side effects and things like that. So that's groundbreaking research to create a vaccine for COVID, right? So you're going to want to replicate those findings to make sure that you get the same or similar outcomes. Also, exact replications by nature, you're building out your research design off of previous research there. So the more you're able to reproduce those findings, the greater confidence you have in the previous research. Now, what happens if you do the research study and you're unable to replicate the finding? So I want you to think about it as, there are many ways to interpret this. First, you can interpret, well, maybe the initial study was flawed, and the Center for Open Science has a reproducibility project, which Brian Nozick is very involved in, which reproduces classics in psychology to see if they're generalizable or reproducible. And I know he had some controversy around this, but he suggested that many studies that are published that we consider landmark studies that are cited in intro to psychology textbooks cannot be reproduced or don't consistently get reproduced. So it's a threat to the original finding. Or another thing could have happened. Well, maybe your replication attempt was flawed. So sometimes editors of journals, they have license to shrink things down, and they might have taken things out of the procedure section of the method, right? So you want to make sure that that didn't happen. So you want to check that. Also, you could have had a sample that was a dud. So a single attempt at replicating that doesn't go your way doesn't mean you get to throw out the original research, because either their research is good or your research is good, but if they're inconsistent, we don't know. So what do? Reproduce it again and again and again. So over the course of many studies, you get a picture of the pattern. And the more often that the finding works, the better it is, right? So, okay. So repeated failure, though, might suggest that the initial findings were a fluke, right? When you set your alpha at 0.05, right? So you say you're willing to accept 5% error. Well, that means you could have made a type 1 error, and that article got published based on thinking there are significant differences when there weren't, right? So that's one way to think about it. It also could indicate that the results are limited to very specific circumstances. So maybe because the population you use are different, the results came out different. And then you also have to consider the fact of fraud or misrepresentation of findings, which we talked about in our research ethics lecture. That's one of the few things in the ethics code that is very black and white. You don't do it. All right. So conceptual replications are even more important for furthering our understanding of behavior. So they're looking at the relationship between the variables themselves, not necessarily the instruments used. So the same independent variable is manipulated, but a different way. The operational definition is different, right? So when we think about that, conceptual replications rely on different operational definitions of the same construct. So if I were to talk about intelligence, for example, you could define intelligence in many different ways. And even if you use a test, you could say, well, I use the Stanford-Binet test to measure intelligence. Someone else could say, I use the Wechsler test for intelligence. Or someone else could say, I use Raven matrices for intelligence. And we're all measuring intelligence, but using different instruments. So we define that variable very differently. So getting replications from a conceptual point of view is also good, right? So you gain additional strength in the outcome if you can replicate it. So now let's talk about generalizations made through literature reviews and meta-analyses. So a literature review is a written summary of the state of the research you are not actually conducting an empirical study of your own. You're telling the reader what findings have strong support, other findings have weak support in research, and when there are inconsistencies in the research. So you're evaluating the state of the research from a narrative point of view. And you might offer future directions for the research. All of this is a literature review. So it's a narrative summary. Whereas when we talk about a meta-analysis, the word meta to anything means to do it to itself. So metacognition means to think about mental processes or think about thinking. Meta-worry might be worrying about how much you worry. And meta-analysis is an analysis of an analysis. So in a meta-analysis, what researchers do is they gather as many studies as they can, and they use statistics, a statistical analysis, to compare the consistency across studies. And then they talk about the effect size, the relative strength of the effect of this relationship. So the difference between a literature review and a meta-analysis: literature reviews are a summary of the literature in a narrative form. Meta-analysis is evaluating, the state of the literature, but from a statistical point of view and measuring the strength of the relationship between the variables. So through effect size. All right. So when we look at treatment models, so there's a debate between which models work better than which, right? So I'm a clinical psychologist, and my predominant approach is cognitive behavioral therapy, but I use psychodynamic principles, I use some family systems, I use some humanistic principles, I use a variety of philosophies and theories in my treatment. So in an early study in the 1970s, they took 375 studies looking at the various modalities of treatment. And what they found on average was that people who received any treatment did better than not receiving therapy. So the 50th percentile of people receiving treatment would be the 75th percentile of people who didn't receive treatment. So in general, therapy is effective. However, what they found was in the general modes of therapy, no approach to therapy was significantly better than the others at treatment outcomes. Now, for some types of disorders, you might lean on one approach more than another. So exposure therapy and behavioral therapy might be useful for fears and phobias, systematic desensitization, right? So subcategories of therapies work better for certain conditions, but in general, all therapy approaches were roughly the same. So when you go to graduate school and you're trained from one theoretical orientation or another, I don't want you to become too beholden to one approach or the other, because you're going to discover the other approaches work as well. All right. So again, effect size is how much of the outcome can be explained by variable X, right? So it gives you, when we talk about the effect size, it gives you the overall average effect size, and then it gives you individual effect size for individual variables. So the overall effect size tells you the general strength of the relationship. So we talked about some goals of research in our initial lecture. And in that, we said there were 4 goals of research, one of which is for program evaluation, and another one was for policy making and whatnot. So in general, psychology wants to promote the betterment of others or promote human welfare. So we see psychological research as profound impact in many applied disciplines in psychology, such as health, such as law and the criminal justice system, education, work environments. And I went through a lot of these in earlier lessons, and that's why I'm not going through it the same way. So I'm going to stop there. I really hope you enjoyed this lecture series on research methods, and you can find it to be useful. So thank you for indulging me across these series of lectures, and I wish you all the best. And feel free to check out other videos on this channel. So I'm gonna stop there. Take care, everyone.